Hello, in this lecture we will find the value of 2 times AP. We will find the size of 2 times AP, or the value of 2 times AP. Actually, we have a triangle ABC. Side AB of the triangle equals to 90 units. Side BC of the triangle equals to 50 units. And the side AC of this triangle equals to 70 units. And we also have a circle, and the center of this circle is point P, and side AC is tangent to the circle in point, we will call this point O. Again, side AC of the triangle is tangent to the circle at point O, and the side BC of the triangle is tangent to the circle at point, we will call that point E. Again, side BC or CB, it is the same, is tangent to the circle at point E. In the next step, we will connect points C and P together with a straight line. Okay, and we also will connect points P and O together with a straight line. Actually, OP or PO is the radius of the circle, because it starts from point P, the center of the circle, and ends at point O at the circle, so it is considered as the radius of the circle, so I will mark it as R. We will connect also points P and E together by a straight line. And PE is also the radius of the circle. I will mark it as R for the same reason, because it exits, the line PE exits from the center of the circle, that is to say from point P, and ends at point E at the circle, so PE is defined as the radius of the circle. Now, actually, we have a rule that if you have a circle and from external point of the circle, let's call that point V. V is external point to the circle because point V is not inside the circle nor on the circle, but it is outside the circle. For that reason, it is called external point of the circle. So if from point V we will draw two tangents to this circle, this will be the first tangent to this circle. Let's call the touching point of the tangent with the circle L, and then we also will draw the second tangent to the circle from point V. Let's call the touching point of this tangent with the circle F. So according to the rule, FL or VF equals to VL. Okay, so VF equals to VL. So when from external point of a circle, that is to say V, you draw two tangents to the circle, then those two tangents are equal to each other. Okay, VF equals to VL. Okay, so actually we can implement this rule in our circle, because in our circle we have point C that is external point to the circle, because point C is not in the circle nor on the circle, so point C is external point of this circle, and from point C we have two tangents to the circle. CO is the first tangent and CE is the second tangent to the circle. So according to the rule that I mentioned, CO equals to CE. Okay, CO equals to CE, because from external point of this circle, that is to say point C, we have two tangents to this circle, tangent CO and tangent CE. Therefore, according to the rule that I mentioned, they must equal to each other, so CO equals to CE. Okay. And as I have already mentioned, also PO equals to PE equals to the radius of the circle. Both PO and PE are the radiuses of the circle, therefore they are equal to each other. So we can write that PO equals to PE equals to the radius of the circle. And also PC equals to itself. We can write down that PC equals to PC so actually we have three sides of the green triangle, three sides of the green triangle, triangle COP, that are equal to three sides of the black triangle, triangle CEP. Again, three sides of the green triangle, triangle COP, are equal to three sides of the black triangle, triangle CEP. Why? Because side CO of the green triangle is equal to side CE of the black triangle, side PO of the green triangle is equal to side PE of the black triangle, and side CP of the green triangle is equal to side CP of the black triangle. Actually, side PC is common side because side PC is actually belongs to the green triangle, and it also belongs to the black triangle. Okay, so as I have already mentioned, three sides of the green triangle are equal to three sides of the black triangle. Therefore, we can deduce that the green triangle congruent to the black triangle. Okay, so we can write that triangle COP, therefore triangle COP congruent to triangle CEP. Okay, because of the fact that three sides of the green triangle are equal to three sides of the black triangle, we can deduce that the green triangle is congruent to the black triangle, or triangle COP congruent to triangle CEP. Okay, so Actually, from the fact that the green triangle is congruent to the black triangle, we can deduce that angle POC, this angle, is equal to angle PCE, or angle POC of the green triangle is equal to angle PCE in the black triangle. I will write it down. Angle PCO in the green triangle is equal to angle PCE in the black triangle. Okay, angle PCO in the green triangle is equal to angle PCE in the black triangle. According to the rule that corresponding angles in congruent triangles are equal to each other. I write it down. Corresponding angles in congruent triangles are equal to each other. Okay, angle PCO in the green triangle is equal to angle PCE in the black triangle, according to the rule that corresponding angles in congruent triangles are equal to each other. The green triangle congruent to the black triangle. For that reason, angle PCO in the green triangle is equal to angle PCE in the black triangle. So if we call angle PCO in the green triangle theta, then angle PCE in the black triangle will be also theta, because those two angles are equal to each other. Okay, I write it down. Angle PCO in the green triangle equals to theta, so this angle also equals to angle PCE in the black triangle, that equals to theta. Okay, angle PCO in the green triangle equals to theta. It equals to angle PCE in the black triangle, that also equals to theta. Okay. Now I will draw triangle ABC again. So this is triangle ABC. Side AB equals to 90 units, side AC equals to 70 units, side BC equals to 50 units. And actually we have a line CP that actually splits angle ACB to two halves, because this angle is theta and this angle is also theta. So actually line CP splits angle ACB to two halves. This is the first half and this is the second half. For that reason, we can call to CP angle bisector. Okay? So CP is angle bisector. Okay, CP is called angle bisector because it splits angle ACB of the triangle to two halves. This is the first half and this is the second half. Okay, so now actually we have the angle bisector theorem. According to the angle bisector theorem, okay, according to angle bisector theorem, an angle bisector in a triangle divides the side that it eats in a ratio that equals to the ratio of the angle sides. I will read it again and then I will explain it in detail. An angle bisector in a triangle divides the side I'll read it again. An angle bisector in a triangle divides the side that it is in a ratio that equals to the ratio of the angle's sides. Now I will explain the theorem in detail. An angle bisector, that is to say, in our example is CP. CP is angle bisector because it divides angle ACB to two halves. This is the first half and this is the second half. So an angle bisector CP in a triangle ABC in our case divides the side that it is. Angle bisector CP in triangle ABC is side AB. Okay, it is side AB in point P. So it divides that side, side AB to two parts. The first part is part AP and the second part is part PB. Okay, it divides part AB to two parts. And the ratio between those two parts, the ratio between AP to PB is AP over PB. Okay, so that ratio equals to the ratio of the angle's sides. So we relate to angle ACB that it actually splits to two halves by the angle bisector CP, and actually ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. So AC over CB is the ratio of the angle's sides, and that ratio, that is to say AC over CB, equals to the ratio that angle bisector CP divides side AB, that is to say AP over PB. Okay, so I will actually write the equation down. Again, an angle bisector, that is to say CP in a triangle ABC, divides the side that it is. CP its side AB, and actually it divides it. CP its side AB in point P, and it divides it to two parts, to part AP and part PB, and the ratio between those two parts is AP over PB. This ratio is equal to the ratio of the angle's sides. We relate to angle ACB, that is split to two halves by CP, and angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. So that ratio, AC over CB, equals to the ratio that CP divides angle that CP divides side AB. That is to say, CP divides side AB in a ratio that equals to AP over PB. So AP over PB, the ratio that angle bisector CP divides side AB, equals to the ratio of the angle's sides, and the ratio between the angle sides is AC over CB. So AP over PB equals to AC over CB. Okay? So I will repeat again, an angle bisector, that is to say CP, in a triangle ABC divides the side that it is, divides side AB in a ratio, actually it divides side AB in a ratio that equals to AP over PB, and that ratio equals to the ratio of the angle's sides, and the ratio between the angle sides is AP over AC over CB. So AC over CB equals to AP over PB. Okay, so the ratio that angle bisector CP divides side AB equals to the ratio of the angle's sides, and the ratio of the angle sides is AC over CB is equals to the ratio that CP divides AB, and CP divides side AB in a ratio that equals to AP over PB, that equals to the ratio of the angle's sides. We relate to angle ACB, and the ratio between angle ACB sides is AC over CB. So the ratio that angle bisector CP divides side AB, that is to say AP over PB, equals to the ratio of the angle sides, and the ratio of the angle sides is AC over CB. So AP over PB equals to AC over CB. Okay? Again, angle bisector CP in triangle ABC divides the side that it is, that is to say divides side AB. Angle bisector CP is side AB of the triangle in point P, and it divides it to two sides, side AP and side PB, and the ratio between those two sides is AP over PB, and this ratio, AP over PB, equals to the ratio of the angle's sides, and the ratio of the angle's sides is AC over CB. Okay, so AP over PB equals to AC over CB. Okay, so now I will write again the equation of this theorem. I will mark it as equation 1. AP over PB equals to AC over CB. Now we will we'll define AP as X. AP equals to X. So actually PB will be equal to AB minus AP. Okay, AB minus AP will be equal to PB. So PB will be equal to AB, that is to say 90 units, minus APX. So 90 minus 6 will be equal to PB again. PB equals to AB minus AP. So AB is 90 units and AP is X. So PB equals to 90 units minus X. Okay? So here in the first equation, we can substitute AP by X because AP equals to X, and we can substitute PB by 90 minus 6 because PB equals to 90 minus 6. So I substituted AP by X because AP equals to X, and PB by 90 minus 6 because PB equals to 90 minus 6. And as you can see from the picture, AC equals to 70 and BC equals to 50 units. So I will write it down. AC equals to 70 units and BC equals to 50 units. Okay, AC equals to 70 units and AC equals to 70 units and AB equals to 50 units. It is given us in the question, so we can substitute AC by 70 and AB by 50 in the first equation. So we'll get that X over 90 minus X equals to 70 over 50. So here I substituted AC by 70 because AC equals to 70 and CB by 50 because CB I made a mistake here. So I substituted AC by 70 because AC equals to 70, and I substituted CB by 50 because CB equals to 50. Here now 70 equals to 7 times 10 and 50 equals to 5 times 10, so we can substitute 70 by 7 times 10 and 50 by 5 times 10. Okay, here I substituted 70 by 7 times 10 and 50 by 5 times 10. Now we have 10 in the numerator and we have also 10 in the denominator, so we can cancel 10. Or we can actually reduce the equation by 10 because we have 10 both in the numerator and in the denominator. Also, okay, so we will cancel 10. So we cancel 10 from the equation. We got that x over 90 minus 6 equals to 7 over 5. Now we will multiply both sides of the equation by 5. We will get x over 90 minus 6 so we multiplied both sides of the equation by 5, so actually 7 divided by 5 times 5 equals to 7, and x over 90 minus 6 times 5 equals to 5x over 90 minus 6. Now we will multiply both sides of the equation by 90 minus 6. Actually, it is allowable to multiply both sides of the equation by 90 minus 6 because x equals to AP. According to our definition, x equals to AP, and it is less than 90 because AB equals to 90 units and x is less than 90. So 90 minus 6 will be a positive number, so 90 minus 6 will never be 0, so it is allowable to multiply both sides of the equation by 90 minus 6. Okay? Okay, so we multiplied both sides of the equation by 90 minus 6. 7 times 90 minus 6 equals to 7 times 90 minus 6, and 5x divided by 90 minus 6 times 90 minus 6 equals to 5x. Now we will open the brackets in this side of the equation. So after we open the brackets in this side of the equation, we got that 7 times 90 equals to 630, and 7 times minus 6 equals to minus 7x. Here we will add 7x to both sides of the equation. We will get 5x plus 7x equals to 12x, and 630 minus 7x plus 7x equals to 630. Now we will divide both sides of the equation by 6. So after we divided both sides of the equation by 6, we got that 12x divided by 6 equals to 2x, and 630 divided by 6 equals to 105. But we also know that AP equals to x, because we defined AP equals to x. We defined it that AP will be equal to x, okay? So we can write it down that AP equals to x. So according to our definition, AP equals to x. So if AP equals to x, 2 times AP equals to 2 times x. So we write it down. Okay. Two times AP equals to 2 times x, but 2 times x equals to 105, and 2 times x equals to 2 times AP, so we can write equation 1 by adding, we write that 2 times x equals to 105, and 2 times x equals to 2 times AP, so we can write that 2 times x equals to 105 equals to 2 times AP. Okay? Here we have 2 times x equals to 105. We wrote it here, but 2 times x equals to 2 times AP. So I added here that 2 times x equals also to 2 times AP. And we have the equation that 2 times x or 2 times AP equals to 105. Okay? So 2 times AP equals to 105 units. Okay. So 2 times AP equals to 105, and actually that is the answer to the question. 2 times AP equals to 105 units. That is the answer to the question. So now I will summarize the lecture. Actually, we wanted to find the value of 2 times AP, and we have a triangle in which side AC equals to 70 units, side CB equals to 50 units, and side AB of the triangle equals to 90 units. And we have also a circle, the center of the circle P, and P is on side AB of the triangle, and CO and CE are tangents to the circle. So according to the rule that if from external point of a circle you draw two tangents to the circle, then those two tangents are equal to each other. So VF equals to VL. So according to this rule, we can actually implement the rule in our circle, and we can deduce that CO also equals to CE because it is external point of the circle, and we have two tangents to the circle from external point of the circle, so those two tangents are equal to each other. For that reason, CO equals to CE. And also PO equals to PE equals to the radius of the circle. Okay, both PO and PE are the radiuses of the circle, so they are equal to each other. And also PC equals to PC. So we have three sides of the green triangle that are equal to three sides of the black triangle. For that reason, those two triangles can go end to each other, or those two triangles overlap to each other. And for that reason, we can deduce that angle PCO in the green triangle is equal to angle PCE in the black triangle, according to the rule that the corresponding angles in congruent triangles are equal to each other. And if we call to angle PCO in the green triangle theta, angle PCE in the black triangle will be also theta, because those angles are equal to each other. And actually I draw triangle ABC again. And actually PC is angle bisector because it splits angle ACB of triangle ABC to two halves. This is the first half and this is the second half. So for this reason CP is angle bisector, and according to angle bisector theorem, an angle bisector, that is to say CP, in triangle ABC divides the side that it hits, divides angle CP, angle bisector CP divides side AB to two parts, part AP and part PB, and the ratio between those two parts is AP over PB, and that ratio equals to the ratio of the angle sides, to the ratio the sides of the angle that is divided to two halves by the angle bisector PC. That is to say, angle ACB consists of two sides, side AC and side CB, and the ratio between those two sides is AC over CB. So the ratio between the sides of this angle AC over CB equals to the ratio that angle bisector CP divides side AB. That is to say, AP over PB, or AP over PB equals to AC over CB. So if we call AP X, PP will be 90 minus 6, and AC is 70 units, CB is 50 units. So we have one equation with one variable. It is very simple to solve it, and at the end we found out that 2 times AP equals to 2 times X equals to 105 units. Okay, so the answer to the question, the value of 2 times AP is 105 units. Okay, thank you very much.